Hello, everybody. This is Brian for Breaking Down Security. Hey, Mr. Betcher, welcome back.
Hey there.
Yeah, it's good to have you back, sir.
Yeah, well, it's good to be back from our episode from last week, right?
Yeah, exactly.
Yeah.
Exactly. Well, I had to run out, which is why it probably sounded like I was trying to run out the door there last week because, it was either that or try to do a podcast in the car at my daughter's karate class, and I just didn't think that would be very good. So we cut that one a little bit short, I think, because I think we left some stuff hanging. And I think we need to go over one last thing from our Buffer Overrun podcast. And Mr. Betcher is about to tell us what that was.
Oh, well, maybe a couple of things. I don't know. We ended with what can be done, right? And we talked about input validation and used STL containers, standard template library containers that have, built-in safeguards in them. And then fuzzing, it's kind of like pen testing for your app, doing some, or your inputs. Fuzzing, that's a whole couple of series of casts in and of itself, right?
Yeah. Well, I've always thought fuzzing was part of the pen testing.
It could be, yeah.
Yeah. Because, it handles a wide range of things, whether it'd be taking input that you've got or,
it's basically throwing a bunch of random or pseudo-random stuff into an input field and seeing what happens.
Yeah, and you were talking about something earlier in the before we started this about bounds checking.
Yes, boundary value analysis.
That's
right?
it.
That's a whole nother topic.
I got to name my
also.
firstborn that. So
yeah, that and your next cat, right?
My next cat will be boundary values checking analysis or whatever.
Yes. So you're checking the boundaries, right? So what happens if you add two positive integers and you get a negative? What the hell happened there?
Well, that's on like 32-bit processing. 64-bit is like massively large integers, aren't they? I mean, we're talking 64 place characters, right?
Yeah. But you never know what's behind that input field, right?
Yeah. Well, I mean, what would happen if you did happen to add, two large positive integers together and it busts your 64-bit or 32-bit limit? What happens at that point?
Well, they either revert, if it's a positive, only, like a unsigned integer, then it's going to go back to 0. Which may or may not be okay or intended, probably not. But if you say a regular integer goes up to 32,000 something, yeah, it'll roll around back to negative 32,000. So, that's what boundary value analysis is about. That and, if you go outside the bounds of your array or your data structure, right? So you can check for that. Now, when I was in college, one of my professors made us load a special class which checked for that. So that way he could determine whether our programs had any memory leaks in it.
Okay.
So when we
that was back when you were using COBOL and Fortran and stuff?
Sure, with the green screens,
with the green screens.
And we go in the basement with our punch cards. Yeah.
Yeah, there
those
you
days,
go. Punch
right?
card.
So, yeah, I had a huge stack, and then it was raining, and they don't go in soggy. It doesn't work.
Sucks.
So
you can write on them and keep them in sequential order that way, right?
Well, yeah, you'd have to write by hand the order. Yeah.
Oh, okay.
So
right on. Okay.
Anyway, let's see. Yeah, so instead of calling new, we would have to new and delete, which were to create a data structure on the heap. We would call the function new and the function delete, which would create boundaries on our whatever we were creating. And that way it could be checked whether or not we wrote data outside of our bounds. So I thought that was a pretty cool way of doing, memory leak checks, or
Okay.
doing some buffer overflows and that sort of thing. And then, of
Yeah.
course, our last, what can be done about buffer overruns is address randomization to help prevent hackers from finding certain exploits. So if you randomize where your addresses are, then it changes every time.
Yeah, but that's not foolproof, though. As we've heard, at least I've heard, it's pretty trivial these days to get around things like ASLR and address layer randomization, that kind of stuff.
Well, it makes it a lot harder, right? Just like adding one bit to your to your key, your encryption key, can double the strength of that key, right?
That's true. Okay. Yeah. All right. So I know that some of the terms that you mentioned in there are going to be new to people if they've never listened to the podcast from last week. But I would suggest that because we did leave it kind of hanging because I was an idiot and thought I could, get a podcast in before I had to go pick up my daughter and take her to karate and stuff. So go back and listen to the buffer overruns. I'm extremely clueless in that one, and I was still kind of clueless on this part here, but I'm getting better because one of the things I'm learning is doing code audits, because that's something I have to do at my job now, or want to do at my job now. So we're going to move on to the actual podcast subject we were going to talk about today, which you mentioned a few things in the previous bit there that actually would fit here as well, having to do with sanitizing inputs and fuzzing and those kinds of things. We're going to be talking about command injection. Now, for people who have listened to the Breaking Down Security podcast since its inception, we have talked about command injection on more than one occasion, specifically in the web application OWASP Top 10 podcast. Which was, kind of an add-on to this, if you want to listen to that one and get more ideas on how it works in web apps. But we're doing it in code, in Python and Ruby and C and C# and all that good stuff.
And it could be applied to web apps as well. I mean, let's not limit it, right?
Well, I mean, I mentioned Python and Ruby, and there are frameworks that use Python and Ruby to do web CMS, content management. So I think, you have your Django's and your Rails and all that stuff. And those are web applications that run in Ruby. So, and I think Django's Python based. So you have, you can still have these, you can still have command injection issues, in your web CMS that way.
Yeah.
So for those of us who've not listened to the podcast previously, what command injection is where a user injects commands into input parameters that are not intended. And so you have to assume from the very outing that any input that you receive in your program can be of a malicious nature.
Yeah, you have to assume that up front. As
That's
you're
right.
developing code or reviewing code, you have to make sure that you keep this in mind and your developers keep it in mind, that don't trust any input.
Yeah, and that's something that most developers, I think, forget, because they're developing for people who are going to want to use their application and not use it necessarily for malicious intent. So if they're building an e-commerce website, they're going to be building it for people who want to buy things. They're not thinking about building it for somebody who's going to try to put in -1, car tires or something like that. They're thinking about people are wanting to buy 4 car tires. So the idea of having a -1 in your input, or having, ampersand tires is, is foreign idea to them.
Yes.
So that's something that they need to think about when they're developing or coding applications that require input.
Right. Yeah, the whole semicolon, ls, dash L, is kind of foreign to most developers as far as inputting what, your name, stuff like that.
That's right.
But let's talk about a couple of types of command injection, and one is SQL injection. And yes, we did talk about this before in the OWASP top 10. SQL injection has to do with injecting commands, database commands into the application.
That's right. And, it's the way that I think the majority of people think of is when they see a search bar in a website, they attempt to, put in the single quote to find out if they can actually cause an error message to occur that would denote that that site is vulnerable to SQL injection. Now, whether or not you think that's a bad thing to do out of hand, or,
it would be unethical to intentionally put single quotes in every input field you see.
There is a gray area there. It depends on who you talk to, if whether or not that's really a naughty thing to do. I mean, if it's expecting input, you're expecting to input. So,
yeah. So, it's so, this is so bad. It's the number one deadly sin in our reference book, the 24 Deadly Sins of Software Security. So it is the worst thing you could possibly do. And why is that? Well, the database holds all your data, right? It's what, hackers are after.
Yeah, and a lot of web applications, of course, are using databases in some manner as a back end, whether it be Postgres or, for larger ones, it could be even Oracle, or if you're using a really simple CMS, it could be a SQLite database. Right.
So basically it allows attackers to run their own queries against your database, things that were not intended. So what do you do to fix SQL injection? Well, again, it all comes back to input validation. If you have an input, you have to validate that input. Treat every user input as hostile.
That's right. And fields that, you can also set different types for your fields. So, if you've got a form to fill out, most names or most, like a name field should only have letters, no special characters necessarily. I mean, there are ways to do it. If you have an Irish or Scottish sounding name, where it's like O'Hara or something like that with an asterisk, there's ways to escape certain characters that you need. Or if you want to hyphenate your name, if you're married and you're a lady or a gentleman who does the hyphenating of their names, there's ways to escape those things. When you're validating your input, make sure that you are whitelisting those things, because the blacklisting thing has been shown to not be as effective.
So use prepared statements and stored procedures.
Let me ask you a question.
Okay.
Because I used to work with you. That's no secret. I heard that term, prepared statements, thrown around a lot at the place with which that we used to work at the place.
Okay. Yeah.
And I heard that it was a very effective way of not having to worry about SQL injection, because these are statements that are already prepared. Is there an example that so they're not statements like sentences. They're like prepared queries, right? So when somebody clicks on a button, it says, I want to see all the users who've done X or something like that, right? Is that how it is? It's a prepared query that is ran automatically that doesn't require input.
Well, it does require input on some fields. So basically it's it's built in the application, an entire statement that that only certain fields are taken by the user, right? So that way they can't be manipulated as such. It's only one statement, right?
But I have heard that there are ways to break out of them. So I was just wondering how you would make a prepared statement more secure, or make it so that, when somebody clicks a button, they're not going to be doing any input whatsoever. It just will automatically query the database. I mean, it's just a matter of reducing things. You're not going to
prevent it.
SQL injection.
You're not going to prevent
100%.
SQL injection 100% with a prepared statement. And we could do a cast on prepared statements as well, although I doubt we will. But it's just another way of coding that statement. And for example, it might be pre-compiled as well, so it's a lot faster.
Oh, right. Okay.
Stored procedures, on the other hand, are procedures that are in the database, and you call them with certain parameters as well. So
they're not the same.
They're not the same. Stored procedures are built in the database, and prepared statements are built in the code.
Okay.
Yeah.
So if you were trying, which one would you prefer if you were trying to stop issues of command injection or input validation issues? Which one is better, or is it just one works better for another scenario than they're equally as good?
It's all your own preference. My preference is to put more of the weight on the database, let it do most of the processing, leave all that to the database, and put your stored procedures or build stored procedures into your application that way.
Yeah, I guess the less that you're sending to the database, the less steps you have to deal with, possible mess up. Because if you have the procedure, sent to the database instead of it being generated inside the database, there could be, issues along the way where it could be modified or changed to
right. And then next, we have deny access to underlying database tables, right? That's even better, right? Do you understand how that is? You have your database tables, which has your sensitive data, right? Mm-hmm. But then you don't allow your application to access those tables directly. You use views and stored procedures to access those tables.
And why would that be important for command injection? So you don't have little Bobby drop tables.
That's right.
Or you don't have or 1 equals 1, where somebody is dumping contents of your database. If the application doesn't have direct access in that manner to your database, then I guess the 1 equals 1 you could still do, but you can't do like drop tables or alter tables or add new records or remove records, that kind of thing.
Right. All you have is your stored procedures and your or your views, right? And a view is just like a query written on the database. It's like a separate table. So if you have your table with all your user data, their account numbers and social security numbers and credit card numbers and all these things, and all you want to do is put a name and an address, you could write a query to build a view that just has names and addresses, and then give your application access to the view, not access to the underlying data structure or tables.
Just give it read-only access. Yeah. Yeah. And that would solve a command injection issue, because you can't. Could you Bobby drop tables of view?
I don't think so.
Could you still do something
I'm
like that?
I'm not a DBA, but I don't think you can just drop a view, especially if you don't have root or SA, whatever privileges on the database.
Okay.
Right.
Well, if you're a DBA and you're listening to this and you're shaking your head or throwing your coffee at the iPad or whatever it is you're listening it on, hit us up on Twitter with the hashtag BreakSec and let us know that we're doing it wrong or something. Because like Mr. Betcher said, we're not DBAs, so feel free to school us.
Right. So my advice would be to build a view and then access the view from your application, not anything else, and have your your account, your application account, only access the view.
Yeah. Okay. So now we're getting into good old command injection. You've got your nice fancy C program or your C++ or C# or
a lot of C's.
It's a lot of C's, yeah. And then there's R and
your C shell.
I think C shell, yeah, exactly. Or your Visual Basic or your VB script or whatever, your scripting languages too. And you're trying to protect against, command injection from an application, from a binary in this case, not necessarily an application, a web application, but from a binary that you're trying to run.
Right.
Yeah.
So this could provide control of the server, whereas SQL injection could provide control of your database. This would be control of your system. And one way to do that is to use like a semicolon, which is a common terminator in most programming languages. So what would happen is somebody would type in an input field, a semicolon, and then another command, right? Like ls-l, or which I mentioned before, or, you know...
Or you've taken a string of text and it's, you know, you've got it inside of quotes, and somebody has been able to modify that string of text to, you know, fix your quotes, you know, halfway through the piece of, or at the end of your text, they've terminated the quote, and then they still have that open quote left, so they use it to run, you know, commands because your program thinks that, okay, I've got my string of text, and then there's this little extra bit. Oh, okay, so it's asking me to do something else over here.
That's right.
Yeah.
Yep. So how do you fix or prevent command injection? Well, the best way to do it is never invoke a system command from within your program, right? So if you're writing a program, use the programming language that you're writing the program in. Don't try to avoid using system commands. I know it's hard, you know, when you can just, say you're writing a Java program on a Linux machine. Wow, it would be so easy just to, list all the files, right, in the directory and load whatever's there, or save something in a certain directory, whatnot. Yeah. So,
yeah, it's funny that, we're talking about command injection when within the last year or so, there was a very famous command injection vulnerability that occurred that pretty much changed the landscape as we know it for vulnerability disclosures. It had a name called Shellshocked.
Oh, yeah. And that was command injection, eh?
That was it. What happened was the way that the environment variable could be used, they were able to terminate one part of it and actually inject additional commands after the semicolon, and Bash would accept those and run those. And 2014 6271 is or 7169, yeah. Bash code injection vulnerability via specially crafted environment variables, or Shellshock.
Nice.
So it still happens. Bash has been around for, I think I remember this one when they talked about it. It was around 2000 when they had first mentioned that was vulnerable, but people thought, oh, it was a feature, that wasn't a big deal to fix, and then somebody had realized that it was actually quite a big deal.
2006, I think. Mr. Julian Assange,
well, yeah, but
right?
Mr. Julian Assange, who at the time was not as awesome as he apparently is now to some people. But no, I mean, it had been mentioned on the OpenBSD mailing list back in the day, and they'd fixed it. So it's about what they did was they took a semicolon and the rest is history. So how does one fix or prevent it? Did we already talk about that? Did you do your whitelisting just like you do with fuzzing your app?
Yeah, whitelist any input fields. You can do that. Again, input validation. Also, least privilege, right? Don't allow your application to run as root or administrator unless you have to.
If it does need to start as root, you can do like Apache does, and what they do is it starts as root, but then it drops privilege down to like the www user or something, and spawns off child processes as www. so yeah, escaping your special characters, whitelisting only what valid characters are needed. It was interesting. What did he say in the book? He had mentioned don't use regular expressions when writing your validation cases.
Yeah, we're going to have to get more info on that.
Yeah, I don't know if it's you use like if statements or something like that to validate. Okay, because you're whitelisting. So assuming if you're whitelisting, there's only a couple of special cases that you would need to validate. You may be able to say, okay, if input equals X, then or X and Y and Z, or X or Y or Z. I guess it'd be ors. Run this, else be naughty or something. Instead of using,
I'm confused.
What? Well, I mean, okay, let's say input a number.
Okay.
So if you're looking for 0 through 9, you would say if the number equals 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 0, do this. Else, say, put a new number in.
Yeah.
He said that, some of these regexes, the way they're saying it, some of the regexes could get complicated. You could write your regex wrong, which could allow for certain cases where command injection could occur because the input they could be given could also be interpreted by the regex as being valid. So they recommend setting up all your cases by hand. Now, I don't know if that's calling an external file or... setting up an if statement or a conditional statement to make sure that your input is correct. That's something we can ask and mention for later. But that was my guess. So one of the things in the command injection chapter that he mentioned that I can talk about almost intelligently is how to handle errors when input is given. I just mentioned it just now with the conditional statement. If your input doesn't match the validation case that I gave you, the 3 things you're supposed to do are signal there was an error, log the error occurred in a log file for your application or in the system log or someplace like that. And also, if you're good enough, you could parse what was given as input and find a way to modify it so that it is correct.
Like remove semicolons, things like that?
You could do that. I've seen...
And everything after it?
Yeah. Or, if you take input, so let's say you're not hyphenating names and somebody puts a hyphen in their name or they put a period or something. You either drop the period or you drop the hyphen and you just concatenate everything together. Or you act like it didn't exist, like you weren't going to take it at all. That's always an option. It's not necessarily the best way to do it. You want to escape all the necessary stuffs that you need. But, parse out, by modifying, you can parse out what's not needed.
Cool. Or replace it with a single quote.
Or make sure that,
Okay. So
when you're doing code reviews...
Yeah.
Especially if you're using object-oriented languages or you're using C or C++, there's certain constructs that you can look at and know that there might be command injection in there.
Okay. Which are what?
So, for like C, if you go and look, if you have the ebook, it's on page 325 for me, but that's because of the font size and everything. That's what I don't like about ebooks sometimes. So there are certain constructs like system, popen, exec LP, exec VP. If you're doing code audits, you want to look at those to make sure that the input is being sanitized correctly. Also, if you're using 32-bit OS stuff, the shell execute family of functions. Make sure that those the input for those are being validated correctly and that you're not having any issues.
Yeah, in Perl, look for backticks, the expression operator. Yeah, all kinds of things. That it means that, hey, you're going to command level, system level commands, right?
Yeah, or the vertical bar operator, which I always thought was the pipe command. Maybe they're calling it vertical bar operator because he just likes to call it that. But when you're piping commands, so if you're doing an ls inside of your application, if there's a pipe there, then you know that somebody can add additional input after that, or make it so that they can add additional commands on the back of your command.
Or if you're auditing Java, you didn't mention this already, did you? Runtime.exe?
Nah.
Oh, man.
No. Runtime exec. Yeah. I've seen that several times at a place that I used to work at, or that Bob used to work at.
Yeah, I have too, which means I need to go back and look at those. I got some work to do this weekend.
And, that's something you can just ask your developers to make sure that, when they do that they're, runtime exec for Java is Java attempted to do secure thing by not giving out any direct facility via a shell, but shells can be so convenient for some people that many people will call this with an argument that explicitly invokes a shell. Wow.
Shells are great.
Well, it's like, okay, I need to run bin sh, but, or I just need to run a command. So instead of doing runtime exec ls, they'll runtime bin sh ls-l.
Yeah.
And then they spawn a shell. That's lovely.
I need to do a regular expression, so I'll use my shell to do that instead of, Java.
That's awesome.
Yep.
Awesome. So, I was doing it the hard way, trying to Google up a vulnerability for code injection, but he actually has a few examples of command injections from the MITRE site. The 2001 1187, there was a CGI script in CSV form that caused command injection. If you have the book, you can see that on the page there.
All right.
Let's see.
Is that it? Talk about anything else?
No, I think the whole summary thing at the end of the document was pretty good. They said, let's see, defensive measures. Oh, yeah, he mentioned when you're running in Perl, there's a taint mode, which it will, if you're running in that mode, it will look for improper input. Oh. If you're looking for something. So if you can run it in your Perl or your Ruby in taint mode, and if you get a number when you're expecting a letter, it will say, oh, no, you can't do that. So that way it's a way of debugging your scripts. I guess that's a good way, too. You want to debug your scripts and stuff before you deploy it. So, I guess the things to come out of this is handle your failures securely if your input validation fails. Using taint defenses if your environment supports it. Avoid using regular expressions, possibly, if you can do input validation and validators by hand. And use whitelisting instead of blacklisting.
Yeah, common themes.
Yeah, I think we're...
Let me get that. Okay. Let me get that for you.
Yeah, I think that was my Bluetooth speaker dying on me. So, I think... I think the takeaways is we're going to see a lot more of our 24 deadly sins being a lot of input validation. I think that's a big deal. And writing clean code doesn't necessarily have to be difficult. You just have to know where your input's coming from and what you're doing with it when you process it.
Yeah, I mean, hacking is all about finding an input field and putting in some interesting stuff into that and see what happens.
That's true. That's true. And you mentioned fuzzing at the beginning of the podcast. That's what you would do here. You're gonna fuzz input. You're gonna put a -1 in a checkout cart or something, or try to buy something with -$5 to see if it will actually process.
Yep.
So, or try to add additional command line parameters or something like that. So. It's good to be able to almost talk about something intelligently with you, Mr. Betcher. It doesn't happen a lot. It's a very humbling experience, actually, because I didn't go to some fancy school with book learning.
We all have our strengths and weaknesses, right?
Yeah. Well, this is one of those things where it's kind of a necessary evil to know a little bit about this so you can talk intelligently to developers. So.
Yeah, I mean, if you don't experience certain aspects of InfoSec or IT in general all the time, you're probably going to be rusty on it, right?
Yeah, yeah. Well, I would hope that if you aren't good at code audits, that you can find somebody in your organization who's a developer who would be willing to, take that developer to lunch and ask him some questions about these things and see if the developers in your organization are really worried about command injection, or what are they doing for code audits. If you're not doing, if you don't know if your organization is doing code audits, you should maybe invite a developer to lunch and find out what they're doing to mitigate those kinds of things. Are they gamifying it where it's like, we haven't had an error in 25 days and the last one was Jim, and well, Jim's not working here anymore, or something like the game is you keep your job if you don't have any bugs.
Oh, come on now. Hey, look for developers who really, really, really use Linux only. And you can get the hardcore developers that use, what was the one you were talking about earlier? The distro?
Gentoo.
Gentoo, yeah. So if you got a developer that's running Gentoo,
using Gentoo,
yeah. So you're doing like C development, just make sure he's not putting in those bash commands into his C program, right?
Yeah. Spawn your own processes elsewhere, buddy. So yeah. So it's important to be educated about these things and find you a nice developer who might actually be able to help school you on some of these things if you're not.
There you go.
Yeah. So, Mr. Betcher and we're on the Twitters. We enjoy talking to people on Twitter. I am at Brian Brake and he is at Betcher Pwned. We have a LinkedIn group. We have a Facebook fan page at facebook.com/breakingdownsec. What else? Oh, our Patreon. Let's see how many people have been on our Patreon. Let's see. Hey, $6, man. That's awesome. Who's what? Oh, it's just you and me. Well, so if you, the thing about Patreon is if you think you get some value out of the podcast, feel free to drop a couple of bucks. You don't have to. Podcast is always going to be free to those who want it. We don't even give out delays because we don't plan well enough in advance to have it done a couple of days in advance. So it will always be free. It's always going to be there because we like educating people, but it's just something that we've had input from people saying, hey, we'd love to support the podcast. How do we do that? So we put that up. You can join us on Patreon there, and we'll give you a shout out. So, hey, good job, Mr. Betcher. Oh. Yeah, thanks for donating to the podcast.
I'd like to thank Brian Brake for donating.
Oh, yeah. Big fat dollar bill, man. US 1D, yeah. So, yeah. We're on iTunes, and we love feedback on iTunes because it makes us happy and makes Apple happy. And, come on back if you've got anything you would like us to discuss on Breaking Down Security. Maybe if you donate enough money to the podcast, it will be maybe we'll make that a Patreon goal one day. If you donate $50, we'll let you come on and you can rant about whatever you want within reason. I don't know. Maybe that's a thing we can do.
Or we'll have a secret cast just for you.
Oh yeah, secret cast. Ooh yeah, maybe like a podcast hidden inside the podcast. That would be a great idea, wouldn't it? Yeah. Well, we'll work on that too. That might be something we'll work on as well. So, all right, everybody. Hope you have a great week, and come back real soon because we like doing these for you. This has been Breaking Down Security from the world headquarters here. We're signing out. Later.
Bye-bye.
See, wasn't that good enough when I mentioned the secret podcast or whatever inside a podcast? See? I probably should stop it now. Damn it. Come on, stop.